Hello students, in this video lecture I am going to discuss the proof of the result that dual of a PO set is a PO set itself. So let me just recall firstly the definition of the dual of a PO set, although I have already discussed the definition of dual of a PO set and some observations regarding the dual of a PO set in my earlier video. But for the sake of this video, let me just recall again what do we mean by dual of a PO set. So let P be a PO set, then the dual of P, which is denoted by P dual, is a set whose elements are same as that of P. So this is one thing. And the second thing is that the relation less than equal to in P dual is defined as follows. For x and y belonging to P dual, if x and y are any two elements belonging to P dual, of course if x and y belong to P dual, then both x and y belong to P as well, because I just told you that the elements of P and P dual are same. So if x and y are elements belonging to P dual, then we say that x is related to y in P dual if and only if we have that y is related to x in P. So this is how we define less than equal to in P dual, that for any two elements x and y belonging to P dual, we say that x is related to y in P dual if and only if. If and only if means that this expression, this particular expression implies this expression and it is also implied by this expression. So the if and only if means implies and is implied by. So if x is related to y in P dual, then the opposite will happen in P, which means that y would be related to x in P. So if x less than equal to y, this holds in P dual, then the opposite relation will hold in P, which means that you have to, y will come on this side and x will come on this side in P, which means that y would be related to x, the opposite relation would hold in P. Now this fact, this line which defines the relation less than equal to in P dual, this we had interpreted when we were discussing the dual of a PO set and the related observations, that basically if you draw the hash diagram or the diagram of P dual, because P dual comes out to be a PO set, which we are going to prove in this particular video, that P dual is a PO set, and because P dual is a PO set, you can draw its hash diagram or its diagram. And when you draw the diagram of P dual, and if you try to see the placement of the elements x and y, then because x is on the left and this y is on the right, so the element which is on the left is lower than the element which is on the right. So y is on the right, so it will be above x and x will be below y. So this is how the elements will be placed in the hash diagram of P dual. There might be other elements in between x and y that can happen, but as far as x and y are concerned, x will be below y because x is on the left and y is on the right. Now this happens in P dual. If you see the diagram of P dual, then for x and y this is how the placement will happen. And if you draw the diagram of P, and if we try to find out where y and x are located, then because y is on the left and x is on the right in P, so this means that x will be at the top of y, x will be above and y will be below. There might be other elements in between x and y about which we are not sure, but as far as x and y are concerned, x will be above y. So which means that from the diagram of P you can obtain the diagram of P dual. The only thing is that you have to just turn the diagram of P upside down. The diagram of P dual is actually the diagram of P inverted. So this is something that we had discussed in detail in the video in which we discussed dual of a PO set and related observations. So now coming back to what we actually have to show in this particular video. Now in this video I intend to show that dual of a PO set is a PO set. So if you have to show that P dual which is the dual of P, is a PO set, then there are three properties that need to be shown: reflexivity, antisymmetry, and transitivity. And these three properties, reflexivity, antisymmetry, and transitivity, are to be shown keeping in mind that P itself is a PO set, which means reflexivity holds in P, antisymmetry holds in P, transitivity holds in P. So keeping that in mind, we are just going to show that the three properties hold in P dual. So let me just show one by one that these three properties hold in P dual. So first of all, let me show reflexivity. Let me show reflexivity in P dual. So now for showing reflexivity in P dual, let me take some element x belonging to P dual. Now of course, because x belongs to P dual, this implies that x belongs to P, because the elements of P and P dual are same. Now as x belongs to P, and we know that P is a PO set, which means that reflexivity holds in P, because P is a PO set, and this implies that x is less than or equal to x in P. And I just mentioned that when some relation, some particular relation holds in P, then the opposite holds in P dual. And how is the opposite obtained? By bringing the element which is on the right to the left, and bringing the element which is on the left to the right, which means that this implies that x, when you bring this x to the left and this x which is on the left to the right, then again we get back the same relation, which means that you get x is related to x in P dual. So this is what we have when you take the opposite relation, and this is nothing but reflexivity in P dual, because x is an arbitrary element. As x is taken to be an arbitrary element, so this particular expression holds for any x belonging to P dual. So this implies that less than or equal to this, this implies that x is related to x. This x is related to x. X is related to x in P dual. So as x is, because now as x is arbitrary, x was any element, as x belonging to P dual, this is arbitrary. This means that this particular expression, this particular line, that x is related to x, is true for any x belonging to P dual, which implies that less than or equal to, this is a reflexive relation, or this is a reflexive relation in P dual, or we can say that reflexivity holds in P dual. So this is the first property that had to be shown. Now coming to the second property that needs to be shown, which is antisymmetry. So antisymmetry in P dual. So now we are going to show that antisymmetry property holds in P dual. Now for showing antisymmetry holds in P dual, let me take two elements x and y belonging to P dual. So let x and y belonging to P dual be such that x is related to y in P dual, and y is related to x in P dual. And what we have to show, that we have to show that x is equal to y in P dual. So now as x and y belong to P dual, this implies x and y belong to P, because the elements of P and P dual are same, and also because x less than or equal to y, this relation holds in P dual, so the opposite holds in P, which implies that y is related to x in P. This holds in P, and because this relation holds in P dual, so the opposite one holds in P, which means that x is related to y in P. This holds in P. So now what do you have? So now we have that, let me write this particular, so these are the two things that we have. This is one relation that we have in P, this is other relation that we have in P. So now as y is less than or equal to x in P, and x is less than or equal to y in P, both these relations hold in P, and we know as far as P is concerned that P is a PO set, which means that because P is a PO set, antisymmetry holds in P. So this, because of antisymmetry of P, this implies that x is equal to y. So, and this is what we were trying to show. So we started with this relation, we started with two elements x and y belonging to P dual, such that x is related to y in P dual and y is related to x in P dual. These two properties hold in P dual, and we have got this, that x is equal to y, which means that antisymmetry holds in P dual. So thus what do you have? Thus we get for x and y, for any x and y belonging to P dual that we take, such that x is related to y and y is related to x. These two things happen in P dual. So we have got that this implies x is equal to y, which implies that this less than equal to, this is antisymmetric in P dual, or in other words antisymmetry holds in P dual. So this is antisymmetric in P dual, or antisymmetry holds in P dual. So this is the second property that we were trying to show, that antisymmetry. So we have established so far we have established reflexivity in P dual, we have established antisymmetry in P dual, and now the third and the last property that we need to establish in P dual in order to show that it's a PO set is transitivity in P dual. So for transitivity, let me take three elements x, y and z belonging to P dual, such that x is related to y and y is related to z, and both these relations happen in P dual. So what is that you have? We have that that the first element is related to the second, and the second element is related to the third. And we have to show, basically what is that you have to show? You have to show that the first element is related to the third, that is x is related to z in P dual. So this is what we have to show. Now again, as you have x, y and z are elements of P dual, so this means that x, y and z are elements of P also, because the elements of P and P dual are same. So as x, y and z belong to P, and now because this particular relation holds in P dual, so the opposite of it holds in P, which means that y will be related to x in P, and the other one, because this relation holds in P dual, so the opposite holds in P, which means that z is related to y in P. So these are the two relations that you have in P. So as x, y and z, they are elements of P, and these two relations hold in P, and P is a PO set, that we know, because P is a PO set, so transitivity holds in P. So because transitivity holds in P, this simply means that that if the first element is related to the second, you can apply, in fact you can apply transitivity in this order. Let me write the elements in a proper order so as to apply transitivity. So you then of course will apply transitivity once they have been ordered in a proper way. So now as so therefore this is what we have, because as P is a PO set, so and we have that z is less than equal to y and y is less than equal to x. I am writing the elements in this order. Z less than equal to y, this relation I write first, and y less than equal to x, this relation I write later on in P. Therefore we have, because P is a PO set, so transitivity holds in P, and transitivity holds in P means that if the first element is related to the second, and if the second element is related to the third, then the first will be related to the third, which means that z will be related to x in P. So what do you have when you use transitivity in P? On using transitivity in P, we have that this implies that z is related to x in P, and now because z is related to x in P, this means that the opposite relation holds in P dual, which means that x is related to z in P dual, and this is what we wanted. We wanted to show this only, because x, y and z, if x, y and z are any three elements belonging to P dual, and we just said that x is related to y in P dual and y is related to z in P dual, then we had to show that x is equal to x is less than equal to z, or x is related to z in P dual. So if the first is related to the second, and if the second is related to the third, our aim was to show that the first is related to the third, and we have got that first is related to the third in P dual. So x is related to z in P dual, and because x, y and z were arbitrary elements which were satisfying these two relations in P dual, so this implies that this particular relation holds for any set of elements x, y and z satisfying relations like these. So less than equal to is therefore is a transitive relation. It's a transitive relation. It's a transitive relation in P dual, or in other words, transitivity holds in P dual. So thus we have that all the three properties are satisfied for P dual to be a PO set. So thus reflexivity is satisfied, thus reflexivity and antisymmetry, thus reflexivity, antisymmetry and transitivity hold in P dual. And because these three properties hold in P dual, which implies that P dual is a PO set. So because these three properties hold in P dual, so this implies that P dual is a PO set. So this result simply says that this is the proof of the result. The proof of the result is complete. So basically the result simply says that if you have any PO set P, then the dual of it, which is P dual, that also is a PO set. So that is what we had to show in this particular video.